Even this is like so super easy. Okay. It's live.
Okay, so we'll start on part 2. Do you want to start, and then we'll just switch off?
Yeah, that's fine. So just to open up that data, and then it says, what is the explanatory variable, which is the independent, which I think is the head. That's what I put, the length of it.
Yep, that's what I got.
Okay.
Okay, then what is the response variable, and that is the body length.
Yeah. Okay, and then it says to create a scatter plot, representing the relationship between head length and body length. And plot below. So I did that.
Okay, did that, yep. Okay, then it says to use the software to compute the value of the y-intercept in the regression line. And I got negative 69.369.
That's what I got. And so then the B1, the slope is 7.400.
Yep. And then what is the equation for the regression line computed by the software? So it's y hat equals negative 69.369 plus 7.4x.
That's what I got.
Perfect.
Okay. It says use the software to draw the regression line on the scatter plot and then post it. Yeah.
Yep, we did that. Okay, and it says for the observed head length of 51 centimeters, what is the observed body length? So it is 343.
Tapping it. Just close. Is that the last question? I can't remember. Or was there more?
There are 2 more. But if yours closed, I can just read them really quick.
Yeah, I'm like, wait.
Okay, so it says use the regression line you obtained in number 2 to predict the body length based on a head length of 51. So I plugged it in the equation and I got 308.031. It says, why are the values different? Explain. So I said that the value in number 13 is the actual data collected because it was like actually in the SPSS. And I said that it's more accurate.
Yeah.
The regression line that was obtained is more of an estimate because it takes in all of the numbers. That's what I said. I don't know if that's right, but
Yeah, sounds right to me.
All right, well then, you want to start on the quiz? It's so easy. That took us like 5 minutes.
I know.
Okay.
I'm so used to like 2-hour meetings.
I know, seriously.
Okay. All right. So.
Okay, pull this one up. Mine's loading. It always takes so long. Okay. Okay, do you have yours pulled up? All right, are you ready?
Yep. I'm ready. So question number 3, given the linear regression equation, y equals 2.0 plus 1.5x, what is the y-intercept? And that's 2.0. Or 2.
Perfect. And then given that same equation, what is the slope? So it's 1.5.
Okay, so given the linear regression equation, y equals -3 plus 0.25, what is the predicted value of y when x equals 16?
Okay.
One.
1. Yep. 1. I love these.
This is like high school math. I am so
I know, it's so awesome. Okay. So the next one, make a scatter plot of the mass self-efficacy data. Of the 3 data shapes introduced in the reading, which shape best describes these data? Make a scatter plot. Okay, confidence score. So the explanatory would be the y-axis.
Yeah.
Okay. Okay. Is that the hot dog shape? I don't even... Shapes, but it kind of looks like a hot dog.
I'm still bringing it up in SPSS. Wait.
Oh, okay. Yeah.
Use the confidence data for the explanatory and the score for the response. Okay, that's what I was looking for. Confidence explanatory, which is the y. Oh, the x. And then
Did you get it?
yeah, I got it up. So what did you put for it?
I got hot dog shape
Okay.
because it's like thicker and long. It's like a straight line. The banana's like a little curve, and then the hamburger's like big
Fat.
and round. Yep, fat.
All right. Okay. One, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data?
So in the reading, it says that for this one, it is appropriate.
That's what I was thinking. Like it's still pretty much a line. It's just a spread out one, right? So
Yeah, exactly. Okay, the next one, how many observations are in the data? Do you just count? What is that?
I think so. So I bottom of that.
So is that just like how many observations? So like 139?
That makes sense to me.
Okay, that's like a weird question. I feel like we've never gotten that question before. All right,
I know.
139.
So yeah, and it's over here on this side. It says a group of n equals 139. If you look in the comments.
Oh, okay. All right. Cool. Okay, so what is the y-intercept? So we have to do that little thing in
Analyze
SPSS.
regression, linear.
Linear. Okay. So confidence is independent. The score is dependent, right?
Yeah.
Okay. All right. So
18.69. Is that what you get?
yeah. Yeah, 18.69. And then the slope is 12.695.
12.695. Is that what you got?
Yeah, that's what I got.
Yeah. It got cut out when you were saying it. And I was like, wait.
Okay. You're like, what? Okay, so what is the predicted value of y when x equals 4? 4 times 12.695. Okay, did you get 69.47?
I am still doing it. I'm still juggling all of
Oh, okay.
that. And then right. Did you just do the math or did you do the whole SPSS?
I just did the equation that we're given, the y plus that equals
That's probably easier.
the y-intercept plus blah, that one. I
Yeah.
can't even think of you know what I'm talking about.
I know what you're talking about. All right. So calculate. 12.5 plus 69.47. What you got?
That's what I got.
I wonder if we would get a different answer just because of rounding. Like if we did the other way. I think, or it'd be the same.
Oh yeah, I don't know.
Yeah. Let me go get my charger real quick. Apparently my laptop is about to die.
Okay, yeah. You'll need that then.
Yeah. I'll be right back.
Okay.
Okay, I'm back.
You got it?
Yeah, I got it. So, just for fun, let me do it this way and see. Let's see. This is 69.469. What did we get?
69.47.
Yeah, and since it says to do to 3, I say we do 469.
469.
Yeah.
How did you do that equation?
So all I did was do the SPSS instructions that they said to do it in SPSS just because of rounding issues. So I figured I'd try that. So so it says all you have to do is just add 4 to the bottom, without adding anything in the score column or the other column, just a 4 in the confidence column. And then go through and do the analyze, regression, linear.
Okay, so you add it in like the data?
Yeah, so you like add it at the very bottom, so like in the 140 row.
So you add it under confidence rating?
Yeah, and go through analyze, regression, linear. Go through that, and then before you do anything, push save. So once that little linear regression pop-up box comes up, push save. And once you push save, push unstandardized on that.
Oh, okay. Use unstandardized, then continue.
Yeah, and just continue, and then okay. And then you got to go back to your data and look, because it fills it in. It'll save a new column. So like after the comments, there's another column that says pre_1. So it brings that up. This is 69.469.5.
Okay, 16. I'm trying to find it.
Seems like so much more work than the equation to me. Like they said it's supposed to be easier.
I don't know if that is
work,
easier,
but
okay, I'm not finding it. Maybe I did it wrong.
okay, so did you go back to data and not to like, so you, not the pop-up window that comes up, but back to the actual where you inputted the 4?
Yeah, where it says like gender, score, confidence rating.
A column that says comments, and then there should be another one after that. It says pre_1.
Okay, I'm just gonna try it again. So analyze, regression, linear, save, unstandardized. Values, unstandardized?
Unstandardized. Sorry, unstandardized.
Okay.
Standardized?
Okay.
It should be unstandardized.
Okay, so I see like variables
Under the predicted. So unstandardized under the predicted, then push continue and then push OK. And then go back to like your main screen where the data is, and then just go like scroll over to the left. No, to the right. The other left.
oh, okay. 69.469. Oh, okay. I was looking on like the model summary, like that thing.
Yeah.
Okay.
Yeah.
Okay.
Back in the data. Like the.
Okay, that's not that bad. All right. Awesome. Thank you.
Just because they said that way you don't run into rounding problems.
Yeah. Well, that's always so weird to me. It's like, why do they give you the equation you're supposed to do in SPSS?
Yeah.
Like,
I know, but so like the equation is, those numbers are rounded too. So that's why they're like, it's the equation. Here's how to find the equation. But if you use the equation, it'll be off because you're using rounded numbers in the equation.
Yeah. Okay. So the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? There's a positive correlation. We can use the largest x value to find the largest predicted value of y. Okay, so you go to the data and you look at its ratings. Is that what you're supposed to do?
I'm thinking 6 would be the largest X value, right?
Oh, yeah. Yeah, it's 6.
And then you just put it into that.
Then you just put that at the bottom?
Yeah. I'm gonna try something.
But then you'd use 0.69? Or, yeah. No, I don't know. No, that doesn't make sense.
Oops. That I got 94. Was it 94.859?
Yeah, 94.859. Okay. Then how many explanatory variables are present in simple linear regression? Just one, right?
Yeah, it should be 1.
Yeah, okay, just one then. That's what I think.
Yeah, I think it's just 1.
Yeah.
Okay. How many response variables are present in simple linear regression?
So that's just one too, right?
Thinking so. Like, are they throwing us off here?
I know. I mean,
Because
it's not saying how many can be, it's saying how many are there, you know? And we've only been using one, so.
Yeah.
And the example in the book was just one as well. So that's why I'm thinking it's just one.
That's what I think. Like, you're only working with.
Yeah, one of each. Yeah.
Like,
Okay.
have a big group of data at the one point. You're only working with just that one, I think.
Yeah.
All right. So the last one says a company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. Measurements they collect include hat size, circumference of the hat, and the lengths of the major and minor axes. Meaning the company wants to know the size of the hat. What is the response variable?
So that would be the size of the hat, right? Variable being predicted.
Yeah.
Right?
I think so. I'm just reading. So, hat size, circumference of the hat, and minor axes.
Yeah, because the size of the hat
Yeah.
depends on the circumference of the hat.
That's what I'm thinking.
Okay, well, let's see how we did. Yay, we got 100.
Yay! They tried to throw us off on those last two. I was going.
I know.
I'm like, Okay.
All right, awesome. We did it.
Yeah. Probably our shortest meeting ever.
I know, seriously. Only like 30 minutes.
Yeah.
All right, well, I guess I will see you next week.
Yeah. Do we have
We have
anything
a
else
meeting
to
next week,
do
right?
this week for our group thing?
Well, we have to describe the data, but I'm supposed to write it up. I think I'm going to ask Kara because she took all of our data. So
Yeah.
I think I'm going to ask her to send that to me. And then if I have any questions about it, I can just like email y'all, you know.
I'm wondering if I got the wrong thing. So like my husband got like the little boxes instead of the bags, which were supposed to be the same size, but all of my data is like twice as big as your guys'. So I don't know if he got me.
Really?
Yeah, so just I'm wondering if I need to go get 10 bags of just regular and redo it.
Well, if it's really like twice as big, you could just like divide it by 2 and just say like that's, you know, because it's not like it needs to be like exact. I mean, they're all different. They're all like,
Yeah.
as long as it's like kind of close to ours, then I don't think it's an issue. But if it's like way bigger, then maybe. But I don't know if you need to go buy 10 more bags. That's like $10 more. Like, you know, I don't know. Unless you want to.
Well, my kids would eat them anyways, so.
That's true. Yeah.
Yeah, they would devour them. They already devoured the other ones. Because I think guys is in like the 50s and mine's like around 100. So I'm like, wait, why is mine double?
Yeah.
So I
Well,
may,
if you want to do that.
maybe I'll go get 10 more bags and count it out, just so like there's no like errors in our data. Just I don't know. We want to be truthful about it. So
That's
all right. So I'll probably do that, and then I'll just email it to you. Each of us has to turn in the assignment like separately. I don't think it's something we can turn in as a group.
No, the collect the data is the only one where you have to turn it in by yourself.
Okay.
The rest of them, it's like
As a group.
writes it up. Only one person writes it up, so you turn it in as a group.
Okay. That's what I wanted to make sure, because I was like, wait.
But I'll do it, and then I'll send it to y'all, and then see if you know, agree or want to make changes or whatever. So.
Okay. All right. Sounds good.
All right. Awesome.
Talk to you next week or maybe before.
All right.
All right.
See you later. Have a good night.
You too.
Bye.